So the second order derivatives notation I explained to you. Derivative is denoted by d2y by dx2. So if I give you y equal to sin x, and if I ask you to find the second order derivative, first you will differentiate once with respect to x. So you will get dy by dx. You differentiate this again. So if you differentiate again, what will be the notation? D by dx of dy by dx. Derivative. And derivative is what? What is the notation for derivative? D square y by dx square. And that is equal to minus sin x. Did you understand the meaning of second order derivative?
Yes, sir.
So what is the meaning of d cube y by dx cube? What do you mean by this?
The 3-time derivative.
So third order derivative, what do you call it? Third order derivative. That means derivative of the second derivative. Do not have an impression that we are multiplying the d into d cube. That's not the thing here. Although the notation stands like that, but the meaning is different. The notation looks this like d multiplied with the dx multiplied dx square. That is true, but actually it means derivative. Can you tell me what the difference between these two? Dy by dx the whole square and d square y by dx square, are they same or different? Are they same or different?
Different, sir.
Different. What does this mean?
The
Square of the first derivative. What does this mean? Differentiate once, differentiate one more time. They both are different stuff. They don't have anything to do with each other. Is it clear? Yes or no?
Yes,
Yes,
sir.
sir.
Okay. Now my question is like this. If x equal to 80 square, y equal to 280, find d2y by dx2. In parametric function, how will you find the second order derivative? So what will you do first? First, you will find dy by dx. So I'm going to find dy by dx. So first, let me find dx by dt. A into derivative of t square. Please pay attention. There's something different. And that became a into 2t. Equation 1. Then I'll take y as 280. I'll find dy by dx. Dy by dt. 2a into derivative of t, which I get as 2a. Then I'll find dy by dx. That is dy by dt divided by dx by dt. So dy by dt is 2a and dx by dt is a into 2t, which will give me 1 by t. Is it fine so much? I don't think this.
Yes.
Now I have to find the second derivative. What should I do with this to get d square y by dx square? What should I do?
Again, take
One
derivative.
more time, do the derivative.
Again, differentiate with respect to what? Which
X.
variable? X.
X.
So differentiate with respect to x. What is the problem you are going to face is left hand side, no problem, d by dx of dy by dx. Right hand side is d by dx of 1 by t. No x in it. But x is not, t is not a constant. When x varies, t also varies. So you can't take derivative as 0. So can you tell me how to differentiate 1 by t with respect to x? How will I differentiate 1 by t with respect to x?
So we can replace t.
Can replace t in terms of x. Okay, that is correct. But little more better method. D d by dx of t raised to minus 1. It is minus 1 into t raised to minus 2 into derivative of t. Like how you differentiate y raised to minus 1. How you would have differentiate y raised to minus 1? The same method. Minus 1 raised to y raised to minus 2 into derivative of y would have come. Derivative of t. So minus 1 upon t square will become minus 1 upon t square. How to remove dt by dx? Look at the equation 1. We have dx by dt. This one's reciprocal is dt by dx. So minus 1 by t square into 1 upon 280. So minus 1 upon 280 cube is your final answer. What Austin you said is also right method, but sometimes we may not be able to eliminate t so easily. So we need answer only in t, then we apply this technique. If you want the answer in x, yes, what you said is correct. So it depends on how you want the answer, you will be applying that idea. Have you followed this?
Yes,
So
sir.
what did I teach you in this? How to find the second order derivative in parametric function. Your answer, you want it to be in t only. That's why we have to do this method. So we have not applied the eliminating method. X is equal to a into theta minus sine theta. And y is equal to a into 1 minus cos theta. Find d square y upon dx square. Find the second order derivative. You can start with me. First, you find dx by d theta. Dx by d theta. A into, don't wait for me. I'm doing it very slowly so that you can do with me. Derivative of theta with respect to theta 1, derivative of sine theta with respect to theta cos theta. Then you take y. dy by d theta. A into d by d theta of 1 minus cos theta. A into sine theta. Now dy by dx. Dy by d theta divided by dx by d theta. So a sine theta divided by a into 1 minus cos theta. Now stop for a minute. If I want to find the second derivative here, it is going to be a little complicated because I have to apply u upon v method. Am I right?
Yes.
So think of
Yes.
simplifying a little more further. Is there any possibility of simplifying this?
Sir,
By
we
using
sir, we can write sine theta as 2 sine theta by 2 into cos theta by 2 and 1 minus cos theta as 2 sine square theta by 2.
excellent, excellent, Kevin. Too good. And 2 sine square theta by 2. So what will be your final answer? Sine theta by 2 got cancelled. So dy by dx is what the answer?
Cot theta by 2.
Cot theta by 2. And this is quite easy to differentiate. So I have to differentiate this again with respect to x now. Why should I differentiate with respect to x? Because we want d square y by dx square. So dy by dx has to be differentiated again with respect to x, then only I will get this. So d by dx of dy by dx is d by dx of cot theta by 2. So left hand side became d square y by dx square. Can I speak another way? Just listen for a minute. Everybody concentrate on the board. 1 minute. It is derivative with respect to x, but the angle is theta. So what you do is divide and multiply with theta. See the way, the same thing only what I've taught you before, but I'm writing in a different way. Is it fine? D theta I've introduced, divide and multiply type. Now derivative of cot theta by 2 with respect to theta is possible. So minus cosec square theta by 2 into derivative of the angle, that gives you 1 by 2. And d theta by dx, what I should do with this? Tell me. From where will I get the value of this?
So dx by d theta.
Dx by d theta from here. Here we have dx by d theta. From here we'll have to replace. So I will write this as 1 upon dx by d theta. So it became minus 1 by 2 cosec square theta by 2 into 1 upon a into 1 minus cos theta. I hope you have understood this. Problem is not solved yet because you need answer in a more simplified form. So 1 minus cos theta also you can make it into half angle. So minus 1 by 2a cosec square theta by 2 divided by 2 sine square theta by 2. So 2 into 2, 4. So cosec raised to 4 theta by 2 divided by 4a. That would be my answer, final answer. So that you are making all in the same angle.